Dear students, today we discuss how the amplitude modulated wave and AM wave is generated using a transistor circuit. The question given is, derive the expression for amplitude modulated wave, or how the amplitude modulated wave is generated, or how the envelope modulation is done, or square law or small signal modulation. All are same. All are indicates the amplitude modulated wave. So the amplitude modulated wave is generated using a transistor amplifier working in common emitter mode. See, it is a transistor amplifier constructed with common emitter mode. It is a NPN transistor. The emitter is biased using the resistors RE and CE, as it is always be given a forward bias. A negative potential is given to the n-type material. Base is always be given a forward bias. So the positive voltage is given through the potential divider resistor R1 and R2. So the positive voltage is given to the base through the resistors R1, R2 with the help of the external power supply plus VCC, and the collector is given a bias, given a reverse bias through the resistor RC, as it is this terminal is made up of n-type material. For the n-type material, a positive voltage is given, so it is under reverse bias. So it is the simple explanation about the common emitter mode amplifier. In addition to this, the carrier wave is given at the base through the transformer T1. The high frequency carrier wave is fed to the base of the transistor through this tank circuit. This CC, this capacitor CC is tuned to the carrier frequency. So this capacitor CC is tuned to the carrier frequency range. So this portion, the induction coil and the capacitor, it is also called tank circuit. This tank circuit allows the carrier wave with a particular frequency. So this carrier frequency is induced here, and then it passing through this potential divider. Here the carrier wave and the positive DC voltage combines here. So the total positive voltage is fed to base voltage, to the base of the transistor, and then a low frequency modulating signal is given here. The low frequency modulating signal is given to the emitter through the capacitor CM, through this capacitor CM. This modulating signal is passing through here, and then it reaches the emitter through the resistor RE. So this carrier wave and the modulating signal combines here. The amplitude of the carrier wave varies with respect to the amplitude of the modulating signal. The amplitude of carrier wave varies with respect to amplitude of modulating signal here, and then the collector produces the amplitude modulated wave is generated across the collector and the ground. So the generated amplitude modulated wave consists of a positive components. It is filtered using the capacitor CC here, and then it is passing through this tank circuit T2. Here, this tank circuit is also tuned to this carrier frequency. So here, this capacitor is tuned to the carrier frequency. So the amplitude modulated wave also consists of a frequency which is equivalent to carrier wave. So the amplitude modulated wave is now transmitted here. See here the amplitude of the carrier. The amplitude of the carrier, so the carrier amplitude varies here. So it generated amplitude modulated wave. So the amplitude of the carrier wave varies with respect to amplitude of the modulating signal. So the frequency remains same. The frequency and phase of the carrier wave remains same. Only the amplitude is varied here. This is the generation of amplitude modulated wave. The resistors R1, R2, R3 and the power supply VCC gives a proper cohesion point, the Q point, Q operating point. The modulation depends upon the percentage of modulation, whether it is converted into 100% or 50%. The percentage of modulation, it depends upon the transfer characteristics of the transistor. The amplitude of the carrier wave changes with respect to amplitude of the message carrying low frequency modulating signal, but the frequency and phase of the carrier is unaltered. So the output voltage, so the output amplitude modulated wave is available here. So it is a simple procedure. It is a modulating signal. This is the amplitude of the modulating signal. It is the carrier wave. Here in x-axis it is a time. In y-axis it is the amplitude. It is the amplitude of the carrier wave. It is the amplitude of the modulating signal. After the modulation is completed, it generates the amplitude modulated signal like this. So here the high frequency carrier wave is represented by the equation EC is equal to EC cap sin omega CT, and the low frequency message carrying modulating signal is represented by EM is equal to EM cap sin omega MT, and the output amplitude modulated wave is represented by the equation E cap. E is nothing but the EMF voltage. E cap is equal to EC cap plus Ki EM cap sin omega MT. It is the instantaneous values of the modulated wave. It is represented by E is equal to E cap sin omega CT. Ka is the proportionality constant. It decides the percentage of modulation. Substitute the value of the E in this above fourth equation. So we have E is equal to EC cap plus Ka EM sin omega MT into sin omega CT. On solving, we get the final equation E is equal to EC cap sin omega MCT plus Ka EM cap by 2 cos omega C minus omega M plus a small correction. So EC sin omega MCT is So the final equation concerns the carrier wave component EC cap is equal to sin omega ct, and the another two components KAEM cap by 2 cos omega c minus omega mt. This lower side band, this is called lower side band, as the amplitude varies with this frequency omega c minus omega m and the amplitude of the modulating signal, and another component KAEM cap by 2 cos omega c plus omega mt is called upper side band. So the amplitude modulated wave consists of three parts. One is carrier wave, second is it is a lower side band, another is it is upper side band.